Okay, we will look for another example of don't care. Okay, don't care on your K-map. Okay, so based on this question, okay, so the diagram below shows the system of a waffle vending machine. Okay, the vending machine offers several combinations of topping and syrups to choose from, and then we also have a table. Okay, so this table, okay, so shows you the selection. Okay, we have button and also the selection of topping and syrup, yeah, and then this is a diagram. Okay. So you need to design the logic circuit, okay, that include truth table, simplify equation using K-map, and draw the logic circuit. Okay. So first you need to understand the question. Okay, so what is all about, and then for the first step, truth table, so you need to think about the variable that can represent the input and also how many output, okay, for this machine, okay, or for this system. Okay, right. So for the first part, which is the input, okay, the input variable for your truth table. So how you will know the variable, okay, of your truth table. So you know that truth table, we have three types: two variable truth table, three variable truth table, or four variable truth table. Okay, only three selection. Okay, so based on this question, okay, so you need to know which one is the input for this machine. Okay, so the input for this machine is actually button. Meaning that this button also will represent the input in your truth table. So based on the button, you have 6 buttons. Okay, button 1 until button 6. Okay, but we only have 3 types of truth table. Okay, which is the largest value or the largest variable is only 4 variable. Yeah, so how you need to choose, okay, which truth table is suitable for this question. Okay, you just refer to the value of your button value. Okay, you assume this value is actually equals to decimal value. Okay, if you remember in chapter 2, truth table, we have combination of binary. Okay, and also each combination of binary will represent one decimal value. Yeah, so that is how you can determine the category or the type of truth table that you can use. Yeah, so based on this question, okay, you need to refer to the largest number, okay, for this button. So the largest number is 6. Okay, and then, okay, you need to convert 6 to binary to determine the number of bits. Okay, 6 in binary is equal to 110, right? So 110, okay, meaning that okay, 6 is equal to 110, okay, in binary. Okay, so this is decimal. Okay, so 110 based on this binary, so you have 3 bits. Okay, 3 bits for your truth table is equal to 3 variable. So 1 bit for 1 variable. So for first step, okay, for your truth table, the number of variable that you can use for your truth table is 3 variable: A, B, and C. Okay, and then when you decided to use 3 variable, meaning that you need to have 8 combination. Okay, 8 combination of 0 and 1. Okay, 8 combination. Right, so next is the number of output. Okay, the number of output. So this is actually the output because this machine is actually to produce waffle. Okay, so this is a waffle, and then on top of the waffle, we have topping and also syrup. Okay, so based on this table, so the output is actually divided into two parts or two type of selection, either topping or syrup. Okay, but you need to refer to the details of each category. For example, for topping selection, Okay, for topping selection, does the topping has the same topping? It's not, right? You have different kind of topping. You have ice cream, okay, you have whipped cream, and you have yogurt. Okay, meaning that for topping itself, you have 3 output, not 1, okay, 3, okay, because we have 3 category of topping. Same goes with the syrup selection. Syrup selection also have 2 selection, which is chocolate and strawberry. So based on my explanation, it shows that output for this vending machine are 5 output. We have 5: ice cream, whipped cream, yogurt, chocolate, and strawberry. So now you can derive your truth table, okay, for your input and also output. Okay, so I will show you my truth table. Okay, so this is the truth table for this question. Okay, so I have 3 input A, B, C, and then you have 8 combination of binary. So each combination of binary represent 1 decimal value. So this is decimal value. And for your output, you have 5 output. Okay, so this is the variable that I use to represent the output. IC is for ice cream, WC whipped cream, YG is yogurt, CH chocolate, ST is for strawberry. Right? So first thing, you just list down the combination of your input. Okay, and then next, okay, you need to fill in the value in your output list. Okay, so based on this question, you only have 6 buttons. But when you list down all the combination for your truth table, you have 8 combinations. Means that you have 8 decimal value. So based on this input, it shows that there are 2 values that not included in this vending machine. Which value? Okay, value 0 and value 7. Okay, because 0 and 7 is actually not in the system. Okay, so this case we consider as this input 0, okay, which is the first combination 0, 0, 0, and for the last combination 1, 1, 1 is not occur, okay, in this system or in this machine. So what happened to the output? Okay, when the input combination does not occur in the system, we don't care the output. Okay, we don't care the output. So what are the value that we need to put in the output? You still need to put something. So for the don't care output, we need to put X. So that's why for the first combination 0, 0, 0, I put all X. For all output, same goes with the last combination of decimal 7, all X. For the other numbers, 1 until 6, so you just refer to this table. Okay, for example, for button number 1, okay, button number 1, the topping selection is ice cream. So that's why I put 1 to ice cream. And then syrup selection is chocolate. So I also put 1 for chocolate. For the other outputs are 0. So if in the question does not give you the logic level, so you just need to create your own logic level logically. Okay. So if the input is activated, automatically you will put 1, okay, in your truth table. So for button number 2, ice cream and strawberry. Okay, ice cream, strawberry. Okay, button number 3, whipped cream, chocolate. Okay, and the rest. Okay, so you just fill in the value based on the table. So this is our first step in truth table. So first step is actually the crucial one for this question, this kind of question, because if your truth table is not correct, so it will affect for the second step and the last step. So you have to make sure your truth table is a correct truth table in terms of number of input, number of output, and the value that you fill in your output list. Okay. So next we will continue for the second step, simplification. Okay, by using K-map. Okay. So I already made the K-map. So because you have 5 output, ice cream, whipped cream, yogurt, chocolate, and strawberry, that's why you need to have 5 K-map, 1 K-map for each output. Okay. Alright, so we go for our first output, which is ice cream. So this is the K-map for ice cream. Okay, you label your K-map and then you map the value. So if your truth table have X value, which is the don't care term, so you need to map, okay, in your truth table, in your K-map, okay, and also of course the value of 1, okay, except for value 0, so you doesn't have to map the value 0, you only map 1 and X. Okay, so based on this truth table, the cell that represent value X is in cell 0 and cell 7. So this is cell 0, and then this is cell 7. So when you refer to the other K-map, the cell that will represent X is actually at the same cell for all K-map. Okay. For the value of 1, okay, you need to refer to your truth table. For example, for ice cream, okay, first value of 1 is actually at cell number 1 or at cell A bar, B bar, and C. So this is A bar, B bar, and C. Second is A bar, B, and C bar. Okay, only 2 value of 1. Okay. Next step, you need to loop, okay, your value. Okay. So how you can loop value if the K-map have X value? So you must remember, you can loop together X with 1 to form a bigger size of loop. Okay, for this case, okay, I loop together the X, okay, with 1. Okay, because if you don't loop 1 with X, okay, only one cell, if you loop only 1, okay, without X, so it will produce unsimplified expression. Okay, because one cell will produce 3 variable product term, if you remember the rules for looping. Okay, but if you loop 2 cell, okay, if you loop 2 cell, for example, for this loop, okay, so what is the product term for this loop? So product term for this loop is A bar, B bar, 2 variable. Okay, same goes with this one, okay, A bar and C bar. Okay. For whipped cream, okay, we continue for whipped cream. So you map value of 1, so at cell number 3 and cell number 4. Okay. So both ones actually loop together with X. For example, for this loop, okay, we loop together 1 with X, and then the balance 1 here, so you also can loop together with this X, okay, because this cell A, B bar, and C bar is actually adjacent with this cell A bar, B bar, C bar, okay, because it's differ only 1 variable. So that's why you can loop together 1 with X, okay, by using this kind of looping, half of circle, okay, sphere. So the expression, you will get this expression, B bar, C bar plus B and C. 2 loops, so that's why you have 2 product term, and then you OR, okay, with both product terms. For yogurt, you also have 2 value of 1s, and then these 2 value of 1 loop together with X, and then it is actually overlap. Okay, so you have 2 loops, and then this is the product term that represent each loop. This is A and B, this is A and C. Okay. For chocolate, Okay, we have 3 value of 1. Okay, at cell number 1, cell number 3, and cell number 5, if you refer to your truth table. So this is cell number 1, this is cell number 3, and then this is cell number 5. So we can loop together with X, okay, to form one loop that include 4 cells. Okay, because this value of 1 adjacent with this one, at the same time, you have 1, okay, at this cell, which is cell A, B bar, and C. And then in the middle is X. So we can loop together. Okay, because X, when X is adjacent with 1, so we can loop together the X. So the size of loop here is 4 cells. So what is the simplified term or simplified expression for this loop? Is actually equal to C. Chocolate is equal to C. Okay, same goes with the strawberry. Strawberry also have 3 value of 1, okay, and 2 value of X. Okay, and this K-map also we can loop, okay, by using this method. Okay, you loop all 4 cells. Okay, because this cell A, B bar, C bar is adjacent with A, B, C bar cell. At the same time, you also adjacent with A bar, B, C bar, and the last one you also have X. Okay, the adjacent for with the all one here, so that's why you get 4 cell for one loop. The expression will be C bar. So this is how you simplify the truth table by using K-map. So based on all K-map, actually we need to loop together one with X. Sometimes there are cases that you don't have to loop X. Okay, you don't have to loop X. Okay, you just take one. So you must remember, we need X when we want to produce bigger size of loop. Okay, bigger size of loop. So sometimes you don't have to loop X. Right. And the last step is actually logic circuit. Draw logic circuit. So this is my logic circuit based on this expression. Okay, so you need to draw one logic circuit that combine all output in one circuit. So you have 5 output: ice cream, whipped cream, yogurt, chocolate, and strawberry. Okay, so when you draw your logic circuit, you must refer to your expression in your Karnaugh Map. Okay, and then you must remember whatever variable here must equal with the variable in your logic circuit, and the variable in your K-map must equal with the variable in your truth table. Yeah, so this is the logic circuit. I think I don't have to explain the drawing part because we have learned previously in chapter 2. Okay, the most important thing is actually the second step, okay, which is this one, simplification using K-map, okay, that have don't care terms, okay, in your K-map. So how you can simplify, how you can loop the value for your K-map. Alright, so I hope you can understand this example, yeah, and then you can apply the simplification of truth table by using K-map. Okay, if the truth table have X value or don't care term.